OAB chair, Professor Ike, Professor Adobamen, you don't want to move to the front? Professor Adosoma, all the profs, are we afraid to sit in the front rows? And leave only... No, you should aspire to be Professor Emeritus at 70. Please, ma, let's move to the front rows. Profs, mas. All the profs in the second row. And then in that order, please, let's move forward, please. Next seats. Uncle, you are looking at me. Next seat. Yes. Just leave the first 4 seats. Just in case we have former vice chancellors. Thank you, Mars. Please, sir, let's feel. Thank you. Let's move forward. Let's order about that because the procession is about to. Thank you very much. Please. They are coming. Please, let's fill from this middle. Let's fill the front rows, please. Please, move to first 6 or 7 seats. Thank you, sir. Please, let's do that quickly. Please rise for the session. Chancellor's procession is led in by the Deputy Registrar, Senate Matters, Mrs. Comfort Ehigiato. On the Vice Chancellor's entourage, in the order in which they are coming into the arena, we have directors of institutes, directors of academic programs and units, deans of faculties, the dean of students, of postgraduate studies, the provost of the College of Medical Sciences, principal officers of our university, the librarian, the bursar, the registrar, the deputy vice chancellors, and of course, the captain of the ship, the vice chancellor, Professor Lillian Imwetinya Salami, the vice chancellor's procession. On the vice chancellor's procession is also the inaugural lecturer for today. Please remain standing. First 2 stanzas of the national anthem. the Uniben anthem. Uniben. Please. Our dear number one Vice Chancellor in the entire university system in Nigeria. Please put your hands together for the number one Vice Chancellor. The transformational and vivacious Professor Chief Lillian Imwetinya Salami. Other principal officers of our great university, the provost, deans and directors, the inaugural lecturer and family, professors emeriti, other esteemed professors and scholars here present, top government functionaries, your royal highnesses, greatest Uniben staff and students, invited guests, gentlemen of the press, distinguished ladies and gentlemen, we welcome you heartily to this 313th in the inaugural lecture series of the University of Benin. Today's lecture, titled Suffering and Pain in Human Existence, Electrical Power and Machines as Panacea, is to be delivered by an erudite scholar and a professor of electrical power engineering, Professor Samuel Osamudiamen Igbinovia. May I now respectfully invite the registrar of the university, Mr. Ademola Bobola, MNIN, to introduce the Vice Chancellor and the Vice Chancellor's procession. Registrar, sir.
Maybe we should give ourselves some round of applause, at least to celebrate today. Yeah, today is very, very unique. I don't know why the Dean of Engineering is where he is, but I don't want to, because he's so happy today, so joyous. With Madam Vice Chancellor, we received a distinguished alumnus of this university, doing very wonderfully well within Nigeria, Africa, and the world at large in the fintech world. So today is a very unique day when our own erudite professor here who is delivering the lecture has just a crowd within, but has the whole world around the campus because of today's inaugural lecture. So it's quite unique, and so we celebrate God for the glory of this day. It is on this note that I want to present to us the principal officers of this university, particularly beginning from our number one citizen on campus, and who is not just number one on this campus, but actually the number one Vice Chancellor in the whole of the Nigerian university system. For those in the Vice Chancellor's entourage and those who are following us online, and possibly some parents who are here, you know, we had matriculation early today. Obviously, you are seeing the scenes all over. The Vice Chancellor was presented at that occasion, but it is still necessary for me to present the Vice Chancellor in our own usual way. And if she will allow me to speak in a tongue that I'm used to, because she took a title from that kingdom. It is said that Okiki ki kojo, Ariwo ki koshu. That is, if you talk about day every time, even if you talk of day, you will not kill day. Even the whole month, you'll be talking about months, you will never kill months. As we continue to talk about this vice chancellor, she will not be killed, and she will continue to wax stronger and stronger. That's the meaning of the language I've just spoken. Because ordinarily you say, we talked about her when the alumnus came in the morning, and then when we had the matriculation, we talked so much about her, and now we just must talk about her because she's driving this, she's the one driving the affairs. Not only that, she's driving everything excellently. Among the committee of vice chancellors in the whole of Africa, on the platform of Association of African Universities, she's also the vice president in the whole of Africa. And a woman who has married the town and gown, married the academia, and then married it with the society itself. Because the essence of our university is to to really transform the society. And because of that, she has been recognized. And that's why I was able to blow that vernacular without being subjected to any form of punishment. She's the Yeye Meso of Ondo Kingdom. I discovered that the pronunciation of your title is usually not in tandem, so that's why I need to pronounce it very well. Because if I don't know how to pronounce Professor Ayoyunyi very well, I will know how to pronounce the Yemeso very well. Madam Vice Chancellor, I think you will permit me to do that. Professor Lilian Imotian Salami is our dear Vice Chancellor. Supporting our Vice Chancellor today is one of us, very much at home with us, is the Deputy Vice Chancellor Academic, Professor Ray Ozolua. The Deputy Vice Chancellor Kenwa Campus, Professor B.A. Ayinde. The custodian of our finances, we call him the exchequer, the one in charge of our money and the treasury on behalf of the Vice Chancellor, Mr. Gabriel Osadolo, acting boss. We have with us the keeper of our books and publications, Walter Toyo Jonathan Megison, Esquire, acting university librarian. Of course, we have with us once again the Provost College of Medical Sciences, a very reputable arm of this university, known both locally, nationally, and worldwide. Professor Wilson Sado, Provost of College of Medical Sciences. The Dean of Postgraduate Studies, though in acting capacity, is an engineer, is also a distinguished professor, S.A. Aliu. The #1 student on campus, a distinguished professor of economics, Dean Student Affairs, Professor A.C. Iwodao himself. And the host dean today, who is so happy and joyous, and who is going to feed those of us within and those also outside today, after today's inaugural lecture, Engineer Professor E.A. Ogunjo. Dean, but a distinguished professor who has served as Deputy Vice Chancellor Academic at one time in the life of this university, Professor David N. of Faculty of Agriculture. The Dean, Faculty of Arts, Professor S.C. Yuka. The Dean School of Basic Medical Sciences, Professor Freddy Agoreyo. The Pro-Tem Dean, School of Basic Clinical Sciences, Professor V.J. Ekanem. The Dean, Faculty of Education, with the dean, managing, vice chancellor, and all the other very powerful scholars in the education sector of this university, Professor Kingsley Omorogiwa, the dean with a very different apparel from others, because you can see L inverted, but we can guess that one is from Russia, and is the Dean Faculty of Environmental Sciences, Engineer Professor Savio Egiato Irugwe Raphael. He has so many titles, so I just picked a few of them. The Dean Faculty of Law is represented here today by Professor Bright Bazwai. We have the Dean of Life, this time around Life Sciences, not the life that we breathe through our nostrils. Professor Jerry Orwe, Dean, Faculty of Life Sciences. The Dean Faculty of Management Sciences, Professor Inofe. The Dean School of Medicine, Professor Wilson Osarugiabo. And Dean Faculty of Pharmacy, Professor A. Okpara. The Dean Faculty of Physical Sciences, Professor E.O. Ayoyunyi. Don't mind me, I could pronounce that better now. I'm getting better. I'm marking my own script myself. We have with us, representing the Dean Faculty of Social Sciences, Dr. I.M. Aredo. And of course, representing the Director Center for Distance Learning Program, Dr. U.B. Edegwe. Professor E.E. Ugiagwe is the Director Center for Entrepreneurship Development. Professor Hazan Oahena is the Director Center for Educational Technology. The Director of Quality Assurance, the man holding forth for now, Professor Peter Sede. Please, let's give them a round of applause. It's not easy to be a professor. Many nights of writing papers. And the university orator at once upon a time is X this, X that, but currently is the Director, University Advancement and Development Office, Professor Eddie Eragwe. And the Director of Advanced Digital Engineering Center, ADEC, Professor Mrs. Do we put engineer, Professor Mrs. P.E. Orukwe. The Acting Director, Center for Maritime and ICT, the person standing in right now, Dr. E. Ebojo, is there. Blessed are those who have not seen yet believe. He's very much there. The Director Center for African Center for Mushroom Research and Technological Innovation, Professor E.O. Akpaja. And Acting Director, Institute of Education from Ekenwa Campus, Dr. Mrs. I.F. Iyamu. And also from that same Ekenwa Campus, the Acting Director, Institute of Public Administration and Health Services Management, Dr. E.O. Ogato. The Director Center for Research Laboratory and the University Central Research Laboratory, Dr. Andrew Amenagawon. Sorry, we have to manage with that. The leading the Vice Chancellor Central today is the Deputy Registrar in charge of Senate Matters, Mrs. C.I. Eigiato. The day is fast spent, and it is therefore my singular honor and privilege to call our number one citizen and the Vice Chancellor of this university, Madam Vice Chancellor, to present her address. Madam Vice Chancellor.
I must first of all specially welcome you and thank you for piloting through. Whether you all came with helicopters, I don't know, but we've never had it this good, where matriculation is almost translating to convocation, even double convocation. So I want to thank especially the family of the lecturer for today for trying as much as possible to be here, and for all of you who are here present. Thank you. But on a lighter note, I have said that we'll have drone representation of everyone who came here today, so we can also add it to the memoirs of the lecturer today, that he invited the whole city to listen to his lecture. So, distinguished ladies and gentlemen, it is with great delight that I welcome you all to the 313th in the inaugural lecture series of the University of Benin. Today's lecture is the 84th to be delivered in my tenure as the Vice Chancellor of this great university. The third in the Department of Electrical Electronic Engineering, and 20th in the Faculty of Engineering. Ladies and gentlemen, it is my pleasure to introduce our lecturer for today. He is Professor Engineer Samuel Osamudiamen Igbinovia. The title of his lecture is Suffering and Pains in Human Existence, Electrical Power System and Machines as Panacea. Professor Samuel Osamudiamen Igbinovia was born on the 16th of June, 1959 in Benin City to the families of late Augustine Ojo Igbinovia and late Mrs. Grace Igbinovia, Ni Orumesi, both of Ugbine town in Ovia North local government area of Edo State. Between 1966 and 72, he attended first Owina Primary School, Uzebu Quarters, Benin City, followed by St. Patrick Primary School, Benin City, and finally, St. Joseph Primary School, Benin City. He attended Immaculate Conception College, ICC, Benin City, from 1973 to 1977, and later Institute of Continuing Education, ICE, Benin City, where he obtained his West African certificate in 1979. He also attended Government College, Uweli, Delta State, from 1979 to 1980 for his higher school certificate, HSC, but ending at the lower 6. He gained admission into the University of Benin in 1980 to study electronic engineering and graduated with the Bachelor of Engineering degree in 1986. Professor Igbinovia undertook the one-year mandatory National Youth Service Corps, NYSC, at the West African Portland Cement Company, Ewekwere, in Ogun State, from 1986 to 1987. Between 1987 and 1999, he worked at various engineering firms in Edo, Ogun, and Lagos states. Professor Igbinovia obtained a postgraduate diploma in computer science in 1997, Master of Engineering in 1999, and PhD in 2007, all from the electrical, in area of electrical power systems and machine, and his degree and diploma are all from the University of Benin. A true son of University of Benin. Professor Igbinovia joined the services of the University of Benin in 2000 as lecturer 2 in the Department of Electrical Electronics Engineering and rose through the ranks to the position of a full professor in 2014. He has held several administrative positions within and outside the University of Benin. For instance, Acting Director, Center for Maritime Studies and Information Communication Technology, Head, Department of Electrical and Electronic Engineering, Chairman, Technical Committee to analyze financial documents on identifying needs assessment of Nigerian public universities, Assistant Secretary, Nigerian Society of Engineers, Benin Branch, Technical Secretary, Nigerian Society of Engineers, Benin Branch from 2002 to 2005, Faculty Representative, University of Benin Research and Publication Committee, and Coordinator, Faculty of Engineering Lab Practice from 2012 to 2014. Professor Igbinovia belongs to several professional bodies and associations, such as Nigerian Society of Engineers, National Solar Energy Forum, Nigerian Institute for Biomedical Engineering, and International Network of Small Hydropower. Engineer Igbinovia has successfully supervised over 30 Masters of Engineering and 3 PhD theses. He has over 70 publications comprising chapters in books and articles in peer-reviewed journals. He has served as external examiner, assessor, resource persons to several federal and state universities as well as polytechnic, and had attended several local, national, and international seminars, workshops, and conferences. He has also served as an accreditation team member of several universities under the National Universities Commission. Professor Igbinovia is a Roman Catholic faith, is of the Roman Catholic faith, and his hobbies include football, hockey, and reading. He is happily married to Mrs. Ngozi Igbinovia, and the union is blessed with 5 children. He was given the Exemplary Couple Award by St. Augustine's Catholic Parish, Uhege, Benin City, where he has served as a member of the parish pastoral council. Ladies and gentlemen, it is my pleasure to invite Professor Engineer Samuel Osamudiamen Igbinovia to deliver his lecture.
Thank you, Please permit me to stand on the existing. Thank you, Visima. Please permit me to stand on the already established protocol. Visima, I sincerely want to thank you and the management team for the opportunity granted me to stand before you and this great audience for today's 313 inaugural lecture. I want to especially thank Professor F.O. Edeko and Professor A. Aro William, A. Aro Anao, our former Vice Chancellor, for the opportunity to chart the path of academia as Lecturer 2 in 2000 in the Department of Electrical, Electronic, and Computer Engineering. I owe a lot of gratitude and thanks to my academic mentor of blessed memory, Professor P.A. Kwale, and our indefatigable, kind and lion-hearted late Professor Oshodi, Osayuki, JP, who appointed me into various management positions. May their soul rest in peace. Vice Chancellor, my wonderful audience, It behoves me to state that our Heavenly Father, out of his love for mankind, was the first to pioneer the use of electric energy when he stated in Genesis 1:14-16, and he said, "Let there be light." And that light, he allowed the greater light to rule the day and the less night to rule over the night. Out of our disobedience to God, man fell from God's grace, and that preceded the suffering and pain that we experience today. In this inaugural lecture titled "Suffering and Pain in Human Existence, Electric Power System and Machine as Panacea," we drive the inaugural lecture and our understanding today. Suffering and pain in human existence. The Benin man used to say, Madam Vice Chancellor, man, permit me to say that the Benin man used to say, "Use woya, emi onsie." And the Englishman have it as suffering in the interpretation of that event that involves thoughts, beliefs, or judgment and reflect the human experience of pain. Why pain? Thus, suffering is the interpretation of that event and involve thoughts, beliefs, or judgment and reflect the human experience of pain. Why pain is a physical sensation or signal indicating an event with the body. The concept of suffering and pain therefore share negative emotion as a common ground. NIH 2019. Permit me to say, lack of electricity energy in human existence will seriously bring about these concerns. It is clear to everyone here that modern way of life cannot be lived without energy. What I'm invariably saying is that today we know we are all undergoing suffering and pain because of lack of electric energy that drives all the facets of life. We cannot say that we are not suffering as we are here so. And that suffering is an event that your money, even if you have the money, you will not be able to come out of it because of the cost of involving that energy that can make you come out of that suffering and pain. Electric energy crisis. I have before the audience 3 tables. Table 1 is electric energy historical trend in Nigeria, when we started enjoying electricity in Nigeria. This started in 1886, followed by 1896, 1898. The location where that power plant was sited, the installation, the capacity of it, and the statutory body that lorded over those institutions. We have the trend going from 1986 to 1st of November 2013, before Nigeria government understood that electric energy is not what to play with. That led them to the debundling and the regulation of PACN into 6 generating companies, 11 transmission companies, and 11 distribution companies. The question I want to ask, with NEC regulating the principal objectives of this debundling, but the question today, since 2013, are we still undergoing suffering and pain as a result of lack of electric energy in our home, in our setup, where we work? Table 2 shows to us how Nigeria is blessed with energy resources that can drive our power system. The first one there is telling us that we have abundant light crude oil. We have natural gas, we have coal and ignite, up to animal waste, where you can generate from biodiesel and Nigeria is also now looking at nuclear elements of it. But can we come out of it with the way we are going? It is left for all of us to answer. Table 3 is presenting to us generation profile in this country. How many generating stations do we have to cope with the energy demand of this country? Table 3 will show to you that we have 40 power generating stations. What is their total installed capacity? As at June 2023, it was 12,522 megawatts. As at October, it became 14,000 megawatts. 2024, we are looking at 18,876 megawatts. This installed capacity, if you look at column 6, you will see the peak generation and the off-peak generation, 4,602 megawatts. Will that be able to meet our needs? A country that is talking about 220 million, no wonder we are having a very low energy, low capacity that is less than 80 per all of us that is seated here. We cannot even get it. A summary of table 1 and 3 reflects us that Nigeria is blessed with electrical means, largely dominated by non-renewable electrical energy sources. In fact, 1,142 megawatts is from the conventional electric generating station, while only 19% is from renewable energy source. These 4 sectors of electric power industry, made up of generation, transmission, distribution, and electricity retail, which it says, is what the country PHCN was embedded into. Figure 1 and 2 shows the key institutions and players of electric energy supply in the industry in Nigeria. The market value of the end product called electric energy from these 4 sectors in Nigeria, the giant of Africa, is what is pinning the nation to the term suffering and pain in human existence. To buttress this, out of the 36 states we have in this country, as at 2008, Lagos State had a share of 99.3%, while Taraba State had 10.9%. You can imagine what the suffering and pain will be in Taraba State. And this state, they do not have other means that they can use to help themselves. According to World Bank report, Nigeria has the world's largest absolute electricity access deficit of 45% of the population, meaning 90% of Nigerians are not connected to electricity grid. And also, Nigeria ranks 171 out of the countries that were assessed for electricity consumption. And this is a major constraint for the nation's development. 138 years after the first installation of 220 kilowatts power plant in Ijora, in Lagos, 15 years after United Kingdom installed her first plant, we are still talking of a generation of 4,000 megawatts. Figure 1 is showing the key institution, the ministry, Nigerian Electricity Regulatory Commission, Bureau of Public Enterprise, Transmission Company, Nigerian Bulk Electricity Trader, Presidential Action Committee on Power PAC, Presidential Task Force on Power. While on the right-hand side is showing what they are supposed to do, statutory duty, functions. Figure 2 is showing how GENCO, transmission and distribution are interlinked, and who is collecting the money for this different sector, NIBET. That's why we hear every time in the news that we do not have enough money to pay generation company because distribution is not paying, and transmission is not willing to wield the power that has been generated, still bringing us to the suffering and pain. Energy crisis has been a long-time contagious issue in Nigeria. For this reason, Igbinovia Osai 2010 studied electric energy generated and demand trend from 1973 to 2007, a period of 34 years, using the available data. The study showed to us that in power generation, demand, and consumption, there is always what we call non-linearity in power system dynamic values. In the generation growth rate, the index value, population growth rate, and index value, annual average load demand, and the saturation annual load demand, there's non-linearity in it, which is what it's supposed to be. This study showed to us that the power demand or energy demand and supply are growing at an annual exponential rate of 18.56, and the load factor from what we studied was 0.59. The nation's GDP and GNDP and GNP indices cannot be given definite value compared to other nations' value in terms of development. This shows to us that our cost for energy is high because our load factor is less than 100%. If we are able to utilize 100% of what we have, our energy costs will be low. The above findings shows inhibition of adequate electric energy generation and demand. Electricity generation systems. We are going to look at the 4 different ways that energy can be generated from the resources that we have lined. 70% of Nigerian citizens stay in rural area and are cut off from the nation's electric grid, a call for renewable electric energy development. This made Madam Vice Chancellor Igbinovia, Kwale, and Oyeneku to work on mini micro hydro electric power from Ogboma River in Eworo Village 2 in Edo State. Those of us who live around Ekewa Road area towards Jesus Women Church, you must have been hearing Eworo Village. That is where we started our work from on hydro. It's in Ovia Northeast. We have to look at the type of machine that is being used, and we investigated asynchronous machines to function as induction generator, a small hydro project using capacitor. This is the reason for this is that in the rural area, they are not connected to the grid. And so synchronous machine cannot be operated in this area successfully. We need to now know how to use induction motors to operate them so that they can function as a generator. We need to do this using capacitor as the means of excitation. I'm sorry, there will not be time for us to explain what we are talking about here as excitation. But I want to let you know that the power factor of the system regulates the behavior of the electromagnetic device on load, thus determines its operational efficiency. A total 18 houses out of the 700 houses before the operator of the hydro scheme that we worked on died, we are enjoying power continuously, 24 hours by 7, by 30, by 365 days. Unfortunately, the young boy died. He got an attack in the night when he went to operate the hydro scheme. Apparently, some of them in the village didn't want light. They wanted to remain in suffering and pains. The voltage that was generated from this scheme was a pure sine wave, devoid of harmonics, meaning the equipment that they had all through this period were safe, because harmonics, those who are in electrical engineering, know that our equipment, machines do not tolerate harmonics. And so for excitation to be maintained, a certain minimum air gap flux leakage and low dependence are required depending on the capacitor, and the rotor speed. For desired operating voltage, usually 20% above the calculated capacitance value, must be connected across the induction generator winding. In the same vein, Ochukwuba and Igbinovia 2013 also assessed the power potential of a full stream segment at Ofo-Kotumi in Ida region, Kogi State. The two sites were 40 meters apart, and we had to make use of this global positioning system to assess the hydraulic head. Ofu 1 gave us 11.84 meters that can generate 330 kilowatts, while Ofu 2, that has a hydraulic head of 8.6, will be able to generate 118 kilowatts. The kilowatts is related to the annual energy generation. In Ofu 1, it is 2,890.8 megawatts per hour, while in Ofu 2, it is 1,040.69 megawatts per hour. Table 4 presents this Ofu stream. You can see this stream, the flow of the stream. We had to expand it somewhere before we were able to mount the electromagnetic machine that generated the electricity we used to feed Ofu 1 and Ofu 2. This area was where my second PhD student, my first PhD student, got his PhD. Engineer Ochoguba, I don't know if he's around. He's a chief lecturer in Ida Polytechnic. Vice Chancellor, Ma, the projection of generation from hydropower and other renewable sources is to increase at an average annual rate of 1.7 between 2004 and 2030, based on the study of micro hydropower in 1987. We also followed that, and we found out that the annual growth rate is going to increase. Ofu Kopit community is made up of 141 houses with an estimated population of 987 inhabitants. They are all engaged in subsistence agriculture. If you go there, you cannot walk to where I'm standing so on a free earth. You will have to walk on cocoa. Cocoa that has fallen on the ground. Nothing to do with them, because they do not have the means of processing them. And it takes quite a lot to access those areas before they can bring the cocoa out. So they are on the ground, they're perishing. They have resources that they can turn to money, but they are not able because the energy is not there. And so you can also see the suffering and pain they are experiencing over there. They have the agricultural products, but they cannot process it. And the local governments and the politicians there, they are not willing to invest money into them. And so, Table 5 is showing the existing hydropower scheme in Nigeria. The essence of this table is to tell us that we can do better than this. Because Table 2 has shown to us the enormous resources we have in hydro, but we are only able to generate less than 3,000 kilowatts from it. Equation 1, 2, 3 are the basic equation that is used in hydro scheme. You have to determine the flow speed, you have to determine the average discharge, and you have to determine the available power from the hydro scheme. Solar power system. We are looking at how we can come out of suffering and pain in terms of energy provision. That made Igbinovia to work on optimal utilization of solar arrays in 2009. We had a fixed array and we had a motorized array. Motorized is the sense that the panel is being rotated to track the maximum irradiance from the sun. You can see the two plots for a fixed array and the 2 plots for a motorized array to get the maximum power from them. Photovoltaic grid systems are ranked the 3rd fastest growing renewable energy after biodiesel. Ayodele, 1989. We also did some work in wind power. We found out that wind power has the lowest capacity cost when compared to concentrated solar panel and photovoltaic. Using levelized circled cost of energy calculation, we are able to estimate the wind power from the wind at different cut-in speed. We have 4.7 and 5.5 that we took as our experimental at a 10-meter height. Because it is because it's emission-free, ICA and Igbinovia, Urukbe 2022, studied the performance evaluation of a mean permanent magnetic synchronous generator for wind system. This is as presented in figure 7. The aerodynamic power for the wind turbine is as presented in equation 4. We use 500 watt power magnet synchronous generator as our machine. Table 6 is showing to us the input parameter we use in the Simulink. And table 7 is showing to us the output. The first column in the output is showing us the wind speed, and the realizable power from the power magnet is shown on column 5, while the load that it can power is as shown on table 6. In summary, the simulated result in table 7 at a rated output power of 443.3 watts, operating at rotational speed of 488.1 revolution per minute, this corresponding wind speed is 11 meters per second, while the generated output of efficiency of the permanent magnet synchronous generator was estimated to be 86.6%, and the wind energy efficiency was 56.7%. Vice Chancellor Ma, we wish to acknowledge University of Benin, UROPC, and the Tertiary Education Trust Fund that funded this very research that became very successful. And it also produced a PhD student for the university, the person of Dr. Aika. He's a senior lecturer in the Department of Electrical Engineering. Energy selling costs. If you produce, you must sell, and it must be at a particular cost. This made Igbinovia and Osamudiamen in 2009 to make us see if we can get value, because we have earlier mentioned that GDP and GNP values in Nigeria is not there for us to say whether we are developing or we are not developing at all. This made us to find out what is the cost of energy. We did a case study of Delta Power Plant, Delta State. Like I told you, this became necessary because of the clamor in need to attain sustainable development. The findings show to us that the computed index value for Nigeria's GDP and GNP were not encouraging at all compared with nations of the world. Why? Because the thermal station utilization factor of 62.4 to ratio 1 in 2006 did not improve as at 2009. That means we are not progressing. It will surprise you to know that in this study that took us to Sable Power Plant, out of the 11 power plants that were installed, as at this time of study, only 2 were in operation. Only 2 were in operation. And so, we now found out that the cost of generating at that time was 30 naira per 73 kobo per kilowatt hour, while PHCN tariff as at then was between 6 naira to 12 naira per kilowatt, meaning electric energy cost is relatively low and highly subsidized by the federal government of Nigeria. And when we looked at it, we said the way forward is that they should be privatized. We agitated, we said it, we wrote to Sable Power Plant we sent our report to them and told them that this is what you are operating. Can you people survive with this? The manager told us that, well, since they are under government, there's nothing they can do. They cannot increase their cost of selling. This, today, we are seeing has resulted in today's new tariff that has worsened the nation's suffering and pain. We have, for example, University of Benin, our cost of energy has been hijacked from 80 million to 250 million. We are not producing products to be sold. We are producing human beings. And we cannot sell human beings to get this money to pay federal government. That's why Madam Vice Chancellor is not sleeping. She's not sleeping with her team. They are trying to see how we can be taken out of this suffering and pain. We went ahead to look at the power plant modeling for incremental fuel rate. When you are generating, all of us seated here could be regarded as a unit in a power plant that is interconnected. We are all integrated. With plant A be consuming fuel different from plant B, there had to be a standard of fuel rate consumption. This made Amino and Igbinovia in 2013 to look at cost power modeling of Kainji hydro scheme unit using MATLAB. When we got there, we found out that they had 3 types of what we call turbines that is generating the mechanical power that turns the alternator that generates the electricity to be sold. We found out that they were running 3 different turbines, which means their incremental fuel rate will not be the same. Not be the same. And so we were able to establish that the cost of generating scheduled power from the unit using MATLAB, Environment, and SIPME, my able Vice Chancellor was very successful. And it was, as the word was used, it was satisfactory. Minimizing cost of generating electric energy from integrated units at hydro plants, conventional power plant, while certifying the practical equality and equality constraint imposed upon the generating unit, propelled Amino and Igbinovia 2003 to investigate the reality of economic load dispatch, constraint optimization of Kainji hydro system. We found unit 5 to 12 were in operation there, and we had to use piecewise incremental cost techniques to find out the economic load dispatch. I don't know, we don't have time, so let me continue. Unit generation costs were optimized by minimizing the incremental cost function using excess solver. The minimized generation cost resulted in the cost saving of 178,842,145 naira per annum at a targeted demand of 300 megawatts. When you optimize, this is what was saved. If you don't optimize, which means this amount of money you have saved will be added to the cost of production, and this will increase the unit cost from the station. So optimization is a wise thing to do. And we found out that the cost of generating 1 kilowatt hour of energy without optimization and with optimization was 0.346 and 0.276 respectively. All units except IGCs operated on equal incremental fuel rate that we just discussed past, certifying the condition for optimal load dispatch. The advantage of using piecewise incremental cost technique in comparison with other techniques, it requires minimal mathematical expression and minimal assumption for practical optimization. Power control. We cannot be generating without looking at the control. This made Igbinovia and Osamudiamen in 2009 to investigate power station collapse, a case study of steam through gas turbine. In this power plant, they had 6 steam turbines and 4 gas turbines, a total of 1,002 megawatt total installed. If you check the generating trend we provided, you will see the capacity of data there. Vice Chancellor, ma'am, this study of this nature are of paramount importance to aid government policies on energy sector. So I'm sure that was done before they privatized all the power plants. The equation 5 that is before us is the control equation, the transfer function control equation for this non-heat steam turbine. As I said, well, time is not on our side. You need to take part of the output and feed into the comparator that is on the left. That will enable you to control whether first order lag, then the emitter and the dead band. The characteristics of that equation 5 determines whether the system is stable or not stable. In this station, we find out that ST1 caused system collapse in the area 17 times due to disequilibrium between the power generated and the load demand, with the load on the higher side of the beam resulting in system frequency fluctuation, while ST06 caused 19 system collapse with both recording maximum load of 85 megawatts, which is very poor from our study. They cannot even generate up to 75% of what they are supposed to generate. The power station also has parasitic energy of 7.25 above the standard value of F5. The system collapse lies in the lack of improvement of generation, since the generators have been in use for the past 27 years without major overhaul, and a depletion value of 56.7%. And lack of capability to share demand of load among the station units in order to return normal operation, thus suggested complete overhaul or replacement of the 40 units. We cannot be talking of energy generation, transmission, and utilization without looking at environmental impact assessment. This took us to study the environmental impact of all the generating stations, the conventional, the renewable, and the biomass. Table 8 shows the comparison of this impact assessment, the technology that was adopted, the adverse effect. We did it on hydro scheme and nuclear fission reaction somewhere. Fossil fuel, we find out that hydro scheme has the least environmental impact assessment in operation. Emission estimation and control, we also looked at it, and it has presented a relation in relation to what is happening in the global world with the ozone value and the year. You can see it is epileptic. It's not constant. This is dependent on the development of the nation, the stability of the country's economy, and the well-being of the people. Shows the emission. So, emission estimation and control, which we are still battling with, led to the flood from Chad years back that killed so many people along our river bank. IPA 2012. Arising from this, Igbinovia Bello and Inaugural in 2015 investigated the effects and control of pollution from renewable electric plant on the environment using biomass, hydro, solar, and wind in Edo State. We have already said that our energy mix is dominated by fossil, while hydro takes the least percentage. The average noise level measured at the wind turbine operated inside University of Benin at the Energy Center, the value we measured was far, far below the acceptable human hearing level, which means wind, in an extent, has least environmental impact assessment, except when you go into a larger scale. Then you're going to be looking at the effect on the wind on the animals in that area. You have to carry out a survey of the drag force to the wind area. The result obtained from this study has it that pollutant from all forms of energy conversion depends not only on the resource type, but also on the type of configuration of the conventional process and the engineering applied. Three things are involved: the engineering applied, and the process you are taking it through. We also have to look at transmission system. In this area, you cannot generate and store. Electricity is not what you can store. You generate and you evacuate it to the area where it is needed. So you must have the willing equipment on ground. And that is what we call our transmission station. They weigh the energy that is generated from place to place. But in all, we have to look at the low power flow valuation, congestion and transmission losses comparable with the world practice, so that we will, in a way, avoid frequent system collapse. This made Honorable Igbinovia in 2010 deployed MATLAB program to compute bus voltages in the Nigeria electric power system. We had to look at Benin, Ikeja West, Aide, Oshogbo, Benin, and Benin, Ajakuta 330 kV lines, constituting the only loop in the network shown in figure 9. This is showing the circuit diagram, but if you want to analyze it, you will have to take them to the bus admittance arrangement, the Y bus admittance. Before we did Gaussian analysis, and we used power word simulator to look at the congestion, the dip, and the rise at these different buses. And we found out that bus Oshogo, when we use Gaussian, the difference was very okay, not too bad. Using the power word simulator, we also found out the value was not so bad. And we note that the percentage error is as shown on column 3. Earthing power system. Power system is made up of the 4 sectors we mentioned: generation, transmission, and distribution. There must be effective earthing done in all these different sectors so that we do not have issues of equipment damage, properties being destroyed, animals in the area electrocuted, persons electrocution, and fire explosion. If this is not properly done, we all experience it in our own houses, that if the earthing is poorly done, we lose most of our equipment when there's thunder strike. And so the earthing must be effectively done. This made Ubeku, Igbinovia, and Urukbe to carry out extensive earthing system analysis. We need to know whether we should use square configuration, round hole, tapered hole, horizontal laying, and we found out that the square configuration gave us a very good, effective and efficient substation earthing. Distribution systems. Thank you, ma'am. Distribution system. We will not be talking about power failure here and there. It is distribution failure that is making us know that there is power failure. And this is the value that drives the dependability and availability of electric energy in the system, that makes us to say that the GDP and the GMP in this value are below standard value. And so we did extensive work, Igbinovia, Agmontan, at primary on Bender Feeder Flour Mill. We found out that the company is adequately planned and designed In terms of future process line, in the average power consumed, I found it was 58.1% of the total installed power. And this gave us the availability of PACN and the unavailability of PACN. Which means if the unavailability of PACN is higher than the availability, you should expect that the product that is coming from that company will be higher than when the availability of PACN is almost 90%. This is what gives the change in cost price in our products every day, because most of our factories, they rely on their own internal generation. No month of the year did the company not spend more money in running the plant in spite of PACN supply, resulting in unpredicted power collapse. To reduce power outages in this area, we recommend that 3-tier governments must come together. We recommended that there should be adequate training of manpower, and we also ask that corruption in a way should be reduced in Nigerian electric power industry. The study gave real insight to the daily rise in finished product price and slow growth in industrial output. And except Nigerian electric power industry is revitalized using any of the public-private strategies recommended by Ibeku and Emmanuel, outright risk, otherwise the country will continue to experience energy crisis unabated. Causes of power outage: Igbinovia, Osamudiamen, and Odiase in 2021 tried to assess the reason for power outages. We termed it vulnerability assessment or component in the typical rural Nigeria distribution system. We use EHO, Ubiaja 33 kV, EHO, Ubiaja and Uzeba 33 kV feeder for the analysis. We collated using Microsoft ETAP software and statistical tools. We found out that 80% of all faults in power system occur in distribution network, as presented in Volumina ETA in 2011. 93.7% of all false outages are caused by high explosion of the bare conductor to the atmosphere. So many things: vandals, trees resting on the lines, resulting in constant trip-off of the line. So the proportion of the grand total of identified causes to a entire event are evident from this study. Recommendation: we ask that the regular tree cutting and trimming along the network should be done in the entire route. Use of the right size of conductor for new construction and replacements of that size should also be done. Employing condition-based monitoring system, prediction and reliability center maintenance should be integrated in the network. This study will help the utility provider and power system engineers in the design, construction, and maintenance and operation of the distribution network for optimal and improved system. We also looked at the techniques that we can use to forecast load and energy trend. Here, Osamudiamen, Igbinovia, and Odiase use artificial neural network approach for determining the futuristic capacity of power supply in the central part of Edo State, Nigeria, for Iho, Ubiaja, and Uzeba. Figure 11 is showing the algorithm, while figure 12 is showing the trained 3-layer level forward layer for the AN, artificial neural network. Table 10 is showing to us the load growth forecast for Iho, Ubiaja, and Uzeba from 2015 up to 2030. We can from here compute the demand growth rate, and we can also talk of the indices, which we said is required when we are talking of GNDP and GNP. Distributed load on Iho increased from 9.3 in 2015 to 27.1 to 10.8 megawatt by 2030. It flows. In summary, the negative trend presented from the result needs to be attended to if benefit adequate power supply is to be of priority to the regulatory agency in this sector. Recommendation. In the entirety of the 313 inaugural lecture encompassing various sessions with their respective findings and recommendations, it is imperative to address the pressing issue of power generation and distribution in light of Nigeria's rapid growing population, which exceeds 200 million. Despite the existence of 40 generating power plants with a total installed capacity of 252 megawatts and 1876 in 2024, system collapse persists due to fluctuation in frequency response to grid demand, particularly during peak load and off-peak period. To address these challenges, urgent attention is required from federal government and policy makers. Before I end this lecture, I wish to state that ever since the university management have been proactive and ensuring sustainable and sufficient energy in the university. Hence, I served in the following committee: Faculty of Engineering Power Generation for the University of Benin in 2007, Erosion and Energy Control, how we can use erosion in generating electricity, 2011 to 2012, Hydropower Development Study Team, May 2011, Electrical Problem Supply, 2014 to 2015, and Uniben Electric Substation in 2015. Some of this work took us to Ecosodin River, the segment flowing through Ecosodi, how it can be dammed to supply water to that community for irrigation and for power generation. The demand of the Memorandum of Understanding were clearly addressed and reports submitted to University Management. I therefore request the University Management to address the findings and recommendations outlined in the report to chart the way forward in the current energy crisis in the University of Benin and the nation. Madam Vice Chancellor, distinguished ladies and gentlemen, Nigeria is indeed endowed with abundant renewable energy resources, including solar, hydropower, natural gas, biomass, and wind. Embracing these resources offers a pathway to sustainable development and provides a solution to the strain on our power infrastructure. Let us seize this opportunity to harness renewable energy and prepare our nation towards a brighter and more sustainable future. I wish to thank God Almighty, the Alpha and Omega, the lover of His creation, for His grace and mercies and love upon myself, wife, children, siblings, and my household. God utilized our uncles and aunties to guide our lives when we felt all hope was lost. Finally, I send my heartfelt thanks to this esteemed audience, particularly great university students and staff of University of Benin, members of our street community, Ugbine community, Ewudu community, Igbinovia and Obazi family members, very dependable friends and well-wishers for your love and unwavering support. May God greatly reward you all in your endeavors. Amen. Thank you, ma'am.
Thank you, thank you, thank you. More. Thank you. As I now respectfully invite Madam Vice Chancellor to recap the lecture.
Distinguished ladies and gentlemen, I'm sure after today, we'll all have diploma in electrical electronics. With all the equations and figures, and so just to say that since we have a guru amongst us, he's only now just telling us. We hope that the problems we are experiencing in University of Benin will be very, very short-lived. Distinguished ladies and gentlemen, the lecturer, of course, is truly an expert in his area of specialization. He gradually took us through all that he has done in terms of solar, wind turbine, stream, gas turbine, hydro, to at least find out and stop the suffering of the people. He actually said that the lack of electricity, light, continues to cause the populace suffering and pain, in spite of our natural endowment as a nation. These include solar, hydropower, natural, and all others. He has actually recommended that if we must get out of the suffering and pain of our populace, we must, as Nigerians, begin to train better engineers. And I know that Uniben is not one of those not training good engineers. We are training good engineers. We must also emphasize maintenance as well as utilization, and then lack of corruption, that we must emphasize that corruption must not creep into this. And as it continues to creep into the energy sector, the suffering and pain will continue. Distinguished ladies and gentlemen, that is where we end it. Thank you very much.
The immediate family members will now come upstage to join Prof as the Vice Chancellor decorates him. One of my colleagues there said, Prof did not acknowledge his wife. I say, he's a typical Benin man, like my husband. So please put your hands together for Madame. And so we welcome very specially the darling wife of the lecturer, engineer, Mrs. Ngozi Igbinovia. Welcome. We also welcome the children, both those who are here and those who are outside. Emmanuel Igbinovia, Osaze Victor Igbinovia, Gift Igbinovia, Joy Igbinovia, Onyemusa, Ruth Ogie, Osasenaga, Deborah. You are all welcome. We welcome the father-in-law, Lieutenant Commander Anthony Ogie. Welcome, sir. We welcome other family members, Barrister Mrs. Omore Bohai. We welcome Mrs. Ame Edosa. We welcome Edosa. Very specially, the former DVC Ekenwan campus, Professor John Ogene. Please put your hands together. We welcome Professor Fred Oba Edeko. We welcome Professor Kessington Oba Hiagbon. Put your hands together. We welcome Professor PROC Adobame. We welcome the UAB Chairman, Professor Mrs. Eki Ogre. Welcome, ma. We welcome Professor Samuel Aki. We welcome Professor Kingsley Ogbeide. We welcome Professor Uwa Edosoma. Put your hands together. Put your hands together also for Professor Sunday Onohaibi. We welcome the Acting Director, Alumni Relations, Dr. Obeki Stephen Obeki. Put your hands together. We welcome Professor Mrs. Lucy Eriahweme. We also welcome Professor Mrs. Esohe. Welcome all of you, distinguished ladies and gentlemen. And that's how we conclude the 313th in the inaugural lecture series of the University of Benin. We should now rise. That love is still... Thank you, sir. Yes. I thought they wanted to now do the love here. Thank you. So, the Uniben anthem and the third stanza of the national anthem. What we sowed with joy and pride, with good common goal. voice for all. We the third moon clarion call. Arise, mighty men, rot in your land, go fly in your feet, bring him, knowledge for service. Stanza 3. Of all creation, grant this our one request. Help us to build a nation where no man is oppressed, and so with peace and plenty Nigeria may be blessed. Amen. And so please remain standing as the Vice Chancellor's entourage leaves the auditorium.